So let's draw a line. So I start from the point where the cursor is and click, and as you can see it draws a line, which is a bit squiffy because it's not going to be square. So what I can do is I can select orthogonal mode, which means that it keeps the lines either vertical or horizontal. So having selected that, now I can go vertical. I can't get the angles in between, which is very convenient. It also means I can type in, I don't need to type in the X and the Y coordinates. I can just do a dimension that's relative to the first point. So if I wanted about 100 inches long, I can simply type in 100, press return, and it draws a line which is 100 inches long. If I put a dimension on it just to prove it to you, you can see that it's 100 units long, which we're calling inches for the moment. It's a similar thing like you saw with a block. Just delete that. That if I insert a block, I can again dimension that 12 by 12 using the comma in between. And it's now asking, yeah, you've drawn the base, but how high is it? So I type in 12 again, and it has made a block. Now if we turn it onto isometric view, you can see my little 12-inch block again. Okay, so we can now move on to having a little go at actually making something. And what we're going to do today is to make a keep left pavement. Whatever that is, they said. Well, essentially what I did was I made a keep left sign. In the days before, I had a 3D printer out of a piece of plastic tubing, and I put a cap on the top and I put an LED up the bottom. But what it doesn't have is that little bit of curbing around the base. So what I thought I'd do was to design it in 3D to suit that little sign that I made as a good demonstration of a very simple three-dimensional object with a fair amount of detail in it. So first we'll get rid of the demonstration block by pressing delete. And the first thing I'm going to draw is kind of a standardized piece of paving, which is nominally 2 foot by 3 foot. So we can draw that with the cube command, and we can type in the width, which is going to be 24 inches. We can type in the length, which is going to be 36 inches, and we can type in a nominal height. So let's say 2 inches. And what we get is a standardized paving block. Okay, so the next thing to do is I want a half paving block, because this is going to be about 1.5 lengths of these paving blocks. So I could build another block. So 24 by 18 by 2 inches and build it that way. But just as a matter of quick demonstration, I can also divide this into 2 and achieve the same thing. Now, the trick is that once you've divided it, you've not got the original. So what I'm going to do is to copy it over here for a second, and now I can mess about with this one and I haven't lost the original. So it's not an icon on my screen, so if I type in splice and I touch this object, what it's going to ask me for is which way do you want to cut it? Do I want to cut it from there to there, or from there to there, or through the middle, etc. I have to define which axis or plane I'm going to cut it in. So I want to cut it from there to there. So that's going from the z-axis to the x-axis. So that's z to x-axis is the one I'm selecting, and it's now asking me for a point on that plane. So I'm going to define the halfway along, and luckily in AutoCAD it has little prompts. So when you see a triangle, that means it's found a line, or it's found a midpoint of a given line. So I'll select that, and that's picked that up. Specify a point on desired side. So that's, if I want to keep it one side or the other, I would select them, but I don't. So I'm going to select both. which is semi-automatic as its default. And what we've got now is 2 halves of the original. So if I were to delete one, yeah, I've achieved the same thing. So straight off the bat, you can see that there is sometimes more than one way of doing the same thing in a CAD package. Let's get rid of that. So I've now got my paving stone and a half paving stone. What I want to do is to move them together. So I grab that with the move command. I select a point, the little square tells me I'm on the end of a line or a corner, and I can now move it across, and I touch it in the place where I want it to go, but it's in orthogonal, so it won't let me go there, but it would actually latch onto that. But I'll turn off the orthogonal just to show you that it will go like that, and it's moved and snapped to the point that I directed it to. So that's basically the length that I'm going to be making as my pavement. And if I just very quickly, for comparison, I'll draw a block to show you the sort of size I think the little turn left signal light thing is. I can't remember what size it is. I know what it is in millimeters. So there's an interesting demo we can do for converting upwards. So I know, because I've measured it, is that it is 6 millimeters wide. It is about 5 millimeters deep, and it's about 12 millimeters tall, I think, from memory. So if we draw that, I'll just change the colour so that it's obvious what it is. And we now know that that's in the real world model size. So if I multiply that up by a factor of 3, go 3, is that you can see that that is roughly the size that my turn left signal is going to be, i.e. it fits nicely onto my paving stones. Okay, so what's next? Well, I need some curb stones. Now, a curb stone is a piece of concrete. It's not quite a square oblong shape, it's got a slightly chamfered size. So in CAD, again, there's a couple of ways of doing this. One would be to, very quickly I'll demonstrate, is to make a block that was about the right size, and I could use a command, that one there, that enables me to form a chamfer on that block, and it would take a chunk out of it. But the easiest way is to, I'll just delete that, to draw a cross-sectional outline of the object that you want to do, and then we can extrude it. Okay, so the basic dimensions of the curb stone is that it's about 6 inches tall and about 4 inches wide. So we're typing 4 by 6 as a square or a rectangle, and then what I want to do is to cut a chamfer here. Let's turn this on its top so that you can see what I'm talking about. That's the cross-sectional area of my curb stone. So we could try and draw a line. I can pick the middle point, but it's not going to let me select anything other than the midpoint, and that's not sharp enough. I want to be somewhere down here, and I could do it by freehand and get it to lock onto the line. Do that for you now. So I can grab that and I can move it back, and it finds the intersection point and produce the line that way. Or I can actually make a chamfer, he said confidently. So picking the chamfering tool, it's currently set at a distance of 0 and 0. So we need to change that distance. So I press D, and it gives me the opportunity to put in some dimensions. Now don't forget we're in inches are our units. So my chamfer wants to be about 1 inch wide by, what was it, 6 inches low, so call it 4. So if we put in 1, I'm going to get this wrong, aren't I? And the other one as 4. And we now need to select the polyline. So we press P, and it tries to do all of them. Yeah, I didn't think that would work. Right. So the best way to do this is to break it. Well, again, there's more than one way. Nothing's ever simple in CAD. So I could grab that, press explode. So it's now not a continuous rectangle that CAD understands is a rectangle. It's just 4 lines, okay, that I can select individually. And now when I come to do the chamfer, the distance is, it's remembered. So we'll presume that's the 1 inch and that's the 4. Yep, it's showing me that it is. And hey presto, it's done it. But this isn't a fully continuous square chamfered thing. So what we can do is we can press this command, which is a join. And what it allows me to do is to select all those lines, press return, and now it's a continuous lump. So if we turn this on its side, or isometrically, we can use this command, which is extrude. I've got to find it now, that one. And it takes that line and it allows you to create a 3D solid by using the shape that you defined. And all I need to do now is to define the length, which in our case, we'll call it 2 foot, which is 24 inches. So we now have a piece of curving stone. Unfortunately, because we're using the XY plane, which is on the bottom if you like, it's decided to make it vertically, so we need to reorientate it. We use the 3-dimensional rotation command, which now is asking me which plane do you want to rotate it in. So whichever one I touch, it changes colour, and I want to use the red one, so I'll touch the red one, and it's now asking me how far round in terms of angular distance do you want to rotate. And we'll hazard a guess that it's 90 degrees, so I'll type in 90, and yay, got it right. We've now put it on its side, so I can now move that. I'll grab a corner, take it to this block, and we're beginning to get our curbing stones. Now, before I go placing them around, one of the aspects of CAD is that you can replicate things very, very quickly. So I could use a tool that would replicate that many times in a straight line, and then I could then use another tool which would mirror that and put it on the other side. But before we get to that bit, what I want to do is to make some slightly rounded ends, which means that I need that profile that I've just used that is now gone. But the good thing about CAD is that you can go backwards, and essentially it remembers every command I've ever used. So if I press this go back, eventually it gets to the point where I had my profile. And what I can now do is to copy that to there. Now I can go back and use that one as my curve. So just quickly extrude that to 24 inches again, grab it and rotate it on the red one again by a factor of 90 degrees. Oh, wrong 90, so that's 180 to make it the other way around. And I can now move it back to where I had it before, and seconds later we're back in a format where we can keep on working. So the next command we're going to use is Revolve, which is a method of extruding a 2-dimensional object into a 3-dimensional object, but around a fixed axis. So this is going to produce a curve that we're going to find hard to see. So what I'm going to do is going to flip that up so that it's sitting upright. I'll call that 90 degrees. So now it's in the right plane for me. I'm going to revolve it around somewhere around here. Now I want it to be a curve around the front, so that's 24 inches. The center point would be 12 inches away, so I just need something to lock onto when I come to revolve this. So I'm going to draw a line very easily, just as a reference point and nothing else, but delete it later, put my orthogonal on, and define a line that is 12 inches long. So now I've got a point that I can revolve it around. So we select the revolve command, we select the object that we want to revolve, we now select the defining point of what we're going to revolve around, and it asks for a second point because you can do things at weird angles. So, and I push the cursor vertically above that, it says, yep, that's in the Z axis. Press return, and hey presto, it will now revolve it around that 12 inches away point into a curved thing. As you can see there, it's showing me the degrees. So if I type in 90, we would get 90 degrees. That's about as big as they make them. I don't want 100, I want 180, but it wouldn't be made as 180. So I could then move that from there to over here, and I've now got my curved stone. So what I need to do now is to fill in this hole with a paving stone that's curved. Okay, so again, there are a couple of ways of doing it. Some are more complex than others, but it depends what you're trying to do. There might be a time when you need to do it the more complex way because you get a different result. But the easiest way would be to make a disc. So we have a command which is a cylinder. We just move over here and we pick a point in the center of the cylinder, and we now need to define the diameter. So it's actually in radius or diameter. You can choose which one you want. So the diameter is going to be 24, and it's gone for the... Why has it done that? Oh, it does that every time. Don't worry about it. I'll show you how to fix it. So it's put it as a radius of 24 for some strange reason, and we need a thickness which we want to be the same as the paving, so that's 2 inches. And we can very quickly fix that because on my second screen I have another little side menu which defines the object that I've clicked on. So if I escape from that, it goes to general settings, but if I click on an object, it shows me the general information and data about that object in CAD. And it's showing there that it has a radius of 24. So all I have to do is to change that to 12, press return, and hey presto, it's now gone to the dimension which I was after, which is 24. The trouble is that it's a complete disc, and I only want half a disc. So as we showed before, the simplest way to do that is to chop it in half using the splice command. So we select the object, and then we want to find a plane. So again, it's in the Z axis, and it wants a point. So the little cursor point will show me the midpoint, or quadrant. In this case, it's not a triangle, it's a quadrant, which is one of the 4 northwest, east, west corner points. So I'll pick that one, and I want to keep both, so I press return, and it has now cut it into 2 pieces. And what that means is that I can now move that, so I can find the midpoint of that straight line that it's created and pick it up, and I can move it across to my pavement. And we're getting there, aren't we? So I've actually used the other half to go on the back. Oh, missed. So move midpoint to the flat one's midpoint, and hey presto, we're getting there. I'll just delete that. Delete that line. So what do we want to do now? Well, a little bit of information is that CAD is deadly accurate. And the problem with this is that if I were to print it as it is now, the join between the curve and the pavement would simply disappear because it's infinitely small. In CAD's terms, it's 0, and therefore it's not going to print out. So we somehow need to show that, and this is where the artistic license of the designer comes into play. The bit that I'm kind of learning is that there would be a mortar line between them in the real world, and to signify that, we need to somehow put a bit of a trough between those 2 items to show it up as like the crack between the 2 items. And that means that we have to get clever in 2D, 3D CAD and put in a trough. How on earth do you do that? Well, I've discovered I did try putting triangles in, but like the chamfer command, there's also a other command which is like chamfer, which is in 2D fillet, and in 3D it's still fillet, but essentially what it's capable of doing is selecting a right angle edge and putting a little round curve on it. And I think what I'm going to do is I'll show you one and then I'll do all the rest. So what we can do is to select that command, we can go to this front edge here, and you can just see that it's kind of predefined it because it's remembered the last figure, which was a 1-inch radius. And for the front of that edge of that curve, that's probably quite good. So I will select that, and hey presto, magically it's created a curvy edge to that one. But what I want to do is to actually put it on the back edge to define it for that little trough of the fillet. So if I flip it round, hold on to your chairs. Oh, my bollard's in the way. So let's just move the bollard out the way for the minute because it's in the way of my working area. So now we can put in the chamfer on the back edge that's going to form our fillet or little gap between the two items. So I select chamfer again. I can select that edge, but that's too big. That's probably going to be too much. So I can now define the radius as being 0.5 of an inch, which, if you remember, we're going to reduce this by a third. So 0.5 will become 0.13166 of a millimetre. So it's very small, but it should be enough for us to see it when we come to print it out. So we can now accept that, and it's put a slightly smaller chamfer onto that edge. And if I click on that one and I hold on to your chair, we do the same on that one. So we go fillet on that one and press return twice, and we get a little fillet there. So I now want to move this back, which is going to be a lot harder because I haven't got a corner to lock onto. We'll use the bottom one instead. And as you can see there, we now have a little slight trough between the two items, which will hopefully show up in the print and makes that defined edge of all the items.